Hello and welcome to my videos. And in today's video, we are going to look at some cryptography libraries and cryptography algorithms in Python. We are going to explore some basics and some advanced concepts in cryptography. So let's get started. So first of all, you can see on screen. So if you Google any cryptography related encryption decryption programming Python, then you will be redirected, or even on a Stack Overflow or any other forum, you will see in this library. It's very famous, Fernet. It's basically used for symmetric encryption. By the way, if you are not aware of symmetric and asymmetric cryptography, you can watch our one of the previous videos, which is on key encapsulation mechanism or module. This video, in this video we talked about symmetric and asymmetric cryptography and how modern day hybrid cryptography uses best of both these asymmetric symmetric cryptography systems pros, and the cryptography becomes even more stronger, and it becomes more efficient. So this Fernet library is basically used for symmetric encryption. So we only need one key in symmetric encryption. Let me go to code, then we'll again walk through this documentation. So here I have this code. So you have to do pip install cryptography Fernet, this package. And from that, once you install it, then first of all, the first step is to call generate key. So this is our symmetric key, which we are supposed to exchange another party with whom you want to exchange the data. So in case of client server, server would like to exchange this key with client, and client would like to exchange its key with server, right? Basically, it's symmetric key. So server will create and server will exchange with client. And for that exchange, we use asymmetric key, that is some key exchange algorithm like Diffie-Hellman or elliptical curve Diffie-Hellman. So this key is generated. Now this API is so simple to use that you can use it directly, but you won't understand exactly what is the size of key here, and how much strong algorithm, which algorithm you are using inside this encryption mechanism, this function. Let's go line by line. So first, this key is generated, symmetric key. Then what happens is this Fernet is a class inside this library. You pass that key, then it returns some object f, which we use for encryption and decryption, and we pass this secret. This secret is string convert byte string basically, and this is a encrypted ciphertext. We call f.encrypt function. We encrypt this message. When we print it, it prints this byte array here. Okay, and after that, what happens is we decrypt it again using the same object, and it's printing that byte number. So it's very simple code where we are generating key, we are using constructor of that object, we are encrypting it, we are passing secret to this encrypt function using this f object, and we are using this decrypt function of this object, we are passing encrypted text, and then we get the decrypted content. So it's very easy. Now what are the so it looks very easy, but we have to understand the underlying implementation of this algorithm. So here in the documentation, you can see implementation section, and here you will see that this is using AES in CBC mode, and it's a 128-bit key for encryption with PKCS padding. So ideally, the key size of the algorithm matters a lot. It's because the attackers usually, when they try to guess the key, if key size is sufficiently large, then your encryption will take more and more time to get hacked, right? So 128-bit is, although is sufficient in today's world, I would recommend that you should be using minimum at least 256-bit key for encryption, and minimum 256-bit key you should target. And that's the reason I feel this algorithm, this particular library is not very much, I'm impressed, or I would not recommend this particular library. There are some another options that you can use here. You can use this multi-Fernet function here. So what it does is it takes list of keys, key 1 and key 2, the same function we use, right? Fernet.generate key. So we generate two keys and we create list, and then what they are saying is multi-Fernet performs all the encryption option using first key in the list provided, and multi-Fernet attempts to decrypt the tokens with each key in turn. So if no correct key is found, then this exception is thrown. So key rotation is happened. So basically nothing fancy. We provide multiple keys, and it chooses one key, and whenever we try to decrypt, it chooses one key from that list. You can also use password, and this is little bit stronger implementation. And here we are using some key derivation function, that is pbkdf2 hmac, and this kdf, although this is pbkdf2, so this is called as key derivation function. And here there are some new concepts as you can see, salt, and another thing is yeah, you can see iterations also, right? So here the first is algorithm, that is SHA-256. This algorithm is basically a hashing algorithm. So now what is the difference between hashing and encryption decryption? So hashing is a one-way function which transforms the input data into a fixed size string of characters, commonly used for data integrity and data signatures. So that means, so suppose if you buy a bottle of water, then you always check for seal, or any product for that matter. And what that seal means, if seal is intact, that means that water bottle is not opened by anyone else. Something similar, we have, whenever we want to check integrity of the data, so, for that matter, we create hash of the message, and we pass that hash of the message along with original message. And so if attacker tries to modify message, then that key or that checksum becomes invalid. So that's where hashing comes into the picture. So yeah, so hashing is used to check authenticity or integrity of the data. So here this KDF function, it uses we are creating here passing hashes to SHA-256, length we are passing as 32, and now salt. The salt, what is the salt? So salting means adding a random value to input data before hashing to enhance security. So this is the random value. You can see it uses os.urandom, that is random function. So this is 16 byte. So this salt is a random number that is added to an input to just to add more security. But remember that when in a reverse operation, so this is encryption, right? So this hashing is used to create key, and when you want to decrypt it, so this token, when you deliver it to the another peer where you want to decrypt it, you have to make sure that the salt, whatever salt you have used here, that salt, your peer party, it needs to know this salt. Okay, so he's going to use same this KDF function, K derivative function. It is going to retrieve same key, and then only it can decrypt this message. So this was about this particular library. But the disadvantage, as I have told you, that it uses 128-bit key. It uses PK. Other things are okay, CBC mode and other things. But there are some modern techniques like elliptical curve cryptography. Then so you have to use this algorithm AES-256 along with authentication. So that is AEAD algorithm. And in modern days, we also have algorithms to fight with post-quantum world. So that we'll be seeing in next video. So thanks for watching.